Hi folks, welcome back to Physics with Captain Rod. Making this video here to help you understand a little bit about the relationship between potential energy, kinetic energy, and how they change relative to one another. So I'm starting out with this picture, which is the picture from one of the previous videos about potential energies. And what I'm going to do is I'm going to put a datum right here where I did in the previous video. So again, why do you do this? You define where you measure the potential energy from. And again, we're going to talk about Timmy's ball. And just like in my previous video, we're going to assume it has a mass of 1 kilogram. And just like in my previous video, gravitational acceleration, which is about 9.8 meter per second, I'm going to approximate that to 10 meter per second squared for the remainder of the video, just to make it nice and easy. And we're going to imagine that Timmy drops this ball here from position 1. And we know that it's going to accelerate down. And we're going to kind of take a look at it when it's here, at what I'm going to call position 2 at the datum. And at this point, it's going to be moving pretty fast, or, well, at some speed. I would call that normally V2. And then we'll look at it again, maybe here, we're going to call this position 3. Now, you notice there's a little daylight there, and that's important, right? Position 3 is just before impact with the ground. And there's a velocity there, so let's call that one maybe V3. All right, so we got position 1, position 2, and position 3. And what we're going to do is we're going to kind of write some equations here, just talk about how the energies are all related. So first of all, the theorem of work and energy. If we just kind of look at what's happening between 1 and 2, and we write out the work energy theorem, the PE1 plus KE1 plus work from 1 to 2 is equal to PE2 plus KE2. So if if you're in my physics class, we've written this down probably many times at this point. The potential energy terms, the PE1 term. Let's see, I'm going to just write this over here. PE1, I calculated this in the last video. 1 times 10 times 10, 100 joules. And I'll just do this. This thing has units of joules, and again, I went over the units in the last video. The potential energy at 2 is 0, because the height is equal to 0. Potential energy at 3 is, we're down below the datum, so it's minus 1 kilogram times 10 meter per second squared times 3 meters. This ends up being minus 30 joules. Again, I'm just going to put NCU for note consistent units here. So if we kind of think about, right, between 1 and 2, the total energy of the system here, of that ball, was the 100 joules, the PE1 term. So that 100 joules is not only the PE1, but it is the total energy of the ball or system, because the ball's not moving at that point, doesn't have any kinetic energy. The KE1 would be 0 because it's not moving. I'm going to hold off on that work term for now. I always like to talk about work terms last. I'm not quite sure why, but again, the PE2 term, I calculated this over here. The PE2 term is 0. And then the KE2 term, I'm just going to write KE2 for now. Now, kinetic energy is equal to 1/2 mv squared. If the purpose of this video was to calculate that speed, then we could put that there, the 1/2 mv squared, but it's not. I just want to talk about the energy relationships here, the relationships between the potential and kinetic energies. Okay, let's chat about this work term now. As the ball accelerates down, I'm going to draw it over to the side here. It's acted on by the gravitational force, which points down, and the gravitational force is equal to mg. If we ignore air drag for this video, and it'd be a reasonable thing to ignore considering it's a relatively low speed problem, ignoring air drag, there'd be no other forces acting on that ball to worry about. Now, as this ball moves from 1 to 2, right, if we take a look at this, it starts here, and gravity basically pulls it down, accelerating it. Gravity is doing work, increasing the kinetic energy. But that's what the PE1 term is. That's why this is here. Oops. we have already taken that into account when we put the PE1 term in. That is effectively the work that gravity is going to do on that object as it moves from position 1 to position 2. And there's no other forces present, so the work term here would be a 0. As a rule of thumb, this is reserved for non-conservative external forces. So if we tried to, say, incorporate air drag into this problem in some way, shape, or form, we would have a work term. So in this example, though, there are no other non-conservative external forces, especially, ignoring air drag. So you'll notice that the KE2 is equal to the 100 joules. And again, if I wanted to, we could set this equal to 1/2 mv squared and get a V out of it. So basically, this potential energy of the ball got converted to kinetic energy. And the gravity is what does that conversion for you, if you will. Let's take a look at what's happening kind of between 2 and 3. And I could write out a work energy theorem if I wanted to for that. PE2 plus KE2 plus work from 2 to 3 is equal to PE3 plus KE3. And the PE2 term is 0 because we're at our datum. The KE2 term, now we could write 1/2 mv squared for that, but I'm not going to. All right, the KE2 numerically, we already discussed that, is the 100 joules. I'm just going to leave that there. There's no work done other than the gravitational force. There's no other forces to worry about as this object moves from 1 to 2, so we're going to put a 0 there. The PE3 now, we calculated this before, is minus 30 joules. And I'm just going to leave KE3 by itself. Again, we could put 1/2 mv squared there if we were interested in finding the V, but that's not the purpose of this video. I'm just going to leave it as KE3. 3. Now you'll notice KE3 would equal 130 joules, right? So let's think about this 130 joules. This is the work done on that ball as it moves from 1 to 3. Or maybe another way to say it, this is the change in potential energy of the ball. Well, actually it's the opposite of the change in potential energy of the ball as it moves from position 1 to position 3. Probably the best way to think of it, that I think will make the most sense, is it's the work done by the gravitational force. Again, as this ball starts here and accelerates down, the gravitational force is doing work. How much work did it do? 130 joules, which is now a kinetic energy as far as this object is concerned at position 3. So again, this was just meant to be kind of a conceptual video about potential energy and how it relates to kinetic energy terms in the work energy theorem. I hope that this has helped. Have a great day.